It's 5:30 already. Let me introduce you Radomir Dopieralski. He's a Python developer, and he will be talking about reviewing codes.
Okay, hello everybody. I'm going to try to convince you that to use code review systems, not just do code review, but specifically use software that makes it easier for you. Okay, one disclaimer before I start. What I'm going to say applies to larger projects. If you are just, making a 3 months project for your thesis, or just playing around, you probably don't need everything that I said. But once you actually create something that is going to live for several years, and that you are going to have to maintain, the costs of maintenance and of taking care of all this code actually grow very fast, and then all the things I'm going to say about apply. Okay? So why do you even review code? This is actually quite new. They only started that some 40 or 50 years ago. And they found out that the cost of finding a defect and fixing that defect grows very fast the farther away from the developer it gets. So if it gets to the QA finds it. It has to go back to the developers, they have to communicate with the QA, they have to go through the pre-release process again, and so on. If it slips past the QA, it goes to production actually, then the cost of a defect may be tremendous. But if you just catch it at when you are writing that, or your coworker catches that for you, then it's relatively cheap. So one way to save money, to make development cheaper and more reliable, is to actually pay attention to defects while you are coding. Second thing is QA and testing and all that, they catch specific kinds of defects. They won't catch all possible defects. And code review also catches only specific defects. It won't catch everything possible. It usually won't catch some elaborate bug that comes from interaction of different systems and so on, because we are only looking at a small piece of code most of the time. But it will catch some specific kinds of defects that QA and testing won't have. So that's something nice about it. Next thing, training. If you make new junior engineers review code written by senior engineers, they will pick up good patterns, good practices from that code, and they will learn fast. On the other hand, if you make the senior engineers review code of the junior engineers, the junior engineers still learn because the senior engineers will point out their mistakes. And the senior engineers also learn because the junior engineers usually explore the libraries or language or whatever in different ways than the senior engineers learn them. So there is still a good chance they will use something that the senior engineers didn't know about, or something that is just new in the language. I had that myself many times. That's not just knowledge transfer, but that's also transferring the culture, the engineering culture in your company or in your team. If it's an open source project, you are transferring more than just knowledge. They learn about how to do stuff, how to ask people for help, how to decide which of the solutions may be better and so on. They actually get to take part in the process of development, and so they learn faster. Next thing, ownership. So if you reviewed a piece of code, you feel responsible for it, even if it's not the code you wrote. There is a common problem especially in larger teams, where developers will say, oh, that's code, that's part of the application, I didn't write that, it's broken. I don't care about that, and I will not touch it, because it was written by that other guy, and it's completely broken. That's not right? That's not how we should work on software. When you are doing code review, more people feel responsibility for a given piece of code, not just the author. And also more people know about this code and know how it works, so even if the original author falls under the bus or goes to an application, others can fix it. That's the so-called bus factor. How many developers have to be killed to completely kill your company? If that's one, then you are doing something wrong. And the last but not least thing, it's very nice for the developers to know that someone else will look at this code before it goes to production, because it gives you a peace of mind. You feel better, you feel more relaxed. If you know that someone at least will verify that your code works, right? So that's the code review. I'm not going to tell you that you should read the code, because that's obvious already by now. And I'm going to tell you why you should use proper tools for doing it. But first, let's see why you shouldn't be using code review, why you shouldn't be reviewing code. And there is a number of commonly cited reasons why code review didn't work in a certain company. First of them is that to do a proper code review, they call it code inspection at IBM, for instance. And to do it really properly, you have to call the meeting, you have to print out the code, right? You have to sit down with all the team. It's a process that takes a lot of skill to do properly. You have to organize all those people, you have to have a chair that there's people whose turn it is to talk next, and so on and so on. At least at IBM, a little bit. Second thing, time. Reviewing takes extra time. If you are not reviewing code, you can write more code. You get twice as much code written. Everybody wins, right? So if 3 people have to review a given piece of code, that means 4 people wasted time to actually get that thing done, when just a single person could have that done, right? So you are losing money on wasting time, on wasted time. Next time, velocity. This is related, right? So if you don't have to review code, you don't have to also correct this code, and you can write more code faster. So your team has higher velocity, you look better in the statistics. And the last one is happiness. And I suspect that it's actually the most important one. Happiness of the developers. The developers don't like doing code review, and they cite in particular two things when they say why. The first is, I will not follow the advice of those who can't even understand my awesome code. They only hold me back. And the second argument is, I will not waste time reading some horrible code written by them. And if you have probably met developers like that already. And maybe, just maybe, they have a little bit of ego problem in there, and maybe your team would be better if they somehow could manage that problem they have and actually do the code review after all. So let's see how code review software helps you with those problems with code review. First is training. So if you have a well-configured code review system, I'm not pointing to any particular one. Anyone will do, as long as you actually think about what you are doing and configure it properly. You have a well-defined process, like step-by-step process during the review. You don't actually have to train people, you don't have to say, okay, now you are talking, don't argue with yourself, and so on. So you have a well-defined process just because it's encoded in that software. You have something that the user interface people call pokayoke. That is the impossibility. It's impossible to do the wrong thing because you don't have that thing. It's like in the previous presentation, Lawrence said that you cannot possibly, from your program, call the wrong thing because you don't have that thing to call, right? So pokayoke is a similar thing. Like when you are copying a file, if you do it from the command line, you can specify a path that doesn't exist, and that's an error. But if you are doing drag and drop, that's an error that you cannot possibly do, right? Because you have to drop it somewhere that exists. That's an example of pokayoke. And here with code review, you have a lot of those pokayoke moments where there is only one or two or three things that you can do, and all of them are only the good things that you can do, right? You cannot do the wrong thing. Because your process is encoded in the software, it's documented. So you actually know what people are doing when they are working. You don't, it's often, it's common in teams that you think that your process looks like this, but it actually looks completely different. Because people take shortcuts and sometimes workarounds and so on. You can just tell people, okay, click through this, you will learn how to use it. That's self-documenting thing. And most of the tasks, most of the really difficult tasks that you would have to learn to do code review, you can actually automate. We have in our Gerrit several things where you actually have to muck about with Git to do something. But Gerrit actually generates you the command that you have to just copy and paste. That's an example. If you don't actually have to learn Gerrit and think about what you need to do exactly, the review system will tell you. Time. Of course, doing something online when you are already by the computer is faster than doing it in a meeting, synchronizing that meeting, finding time for it. And you can do it faster because you have an overview of all the issues. You have good diffs. You can see what changed. You don't have to look at all of the code. Again, you have automation, so you can have linkers that highlights problems with code. You can have coverage checks that highlight problems with the code. You can have all sorts of helpful scripts running there. You can do it when you actually have time for it. It's not like a meeting scheduled in the middle of your work where you actually are thinking about something else. You are actually paying attention to what you are doing. And it's asynchronous. It's so slower. Remember back 20 years ago when you had to phone into the internet connection where you would download all the emails, disconnect, read them slowly, write the responses, and then in the evening you would connect again and send them. They were much better quality responses than when you just do it instantly, right? Because you had time to think about you could do it in your own pace. So doing things asynchronously usually improves them. Okay, but you can improve your velocity because you can make sure that all the things that are supposed to be in that command, like proper style, documentation, tests, and so on, actually are in this commit when it hits the repository, before it hits the repository. People will point out, okay, very nice change, but you forgot to write a test for it, if you require. Or, okay, you changed the API, but you didn't change the documentation for the API. You can do it right now. And that actually saves you a lot of time, because you don't have to have those grooming wasted sessions where you actually find out what's broken and try to fix it retroactively. You can do it right there when it's being done, right? If you do have, okay, I know I didn't write the test, but the client wants this fixed now, and we have to push it right now. You can do that, but all the rest of the team has to agree on that, and they know that you are including technical debt now. And they have it in the back of their mind that you have to fix it at some point, right? So it's also better transparency. It also improves velocity. And last thing, when you are working around an old problem, and everybody are coming to you and say, okay, the thing you did here, it's ugly. Oh, but I have to do it because we have this architectural problem in there, and it has to be like that. When a lot of people know about this problem, it's somehow easier to fix it at some point. There is more traction to actually fix old problems. I told you about ego already. So code review forces communication. And IT people usually are pretty bad at communication, which is a shame. But there is only one way you can get better at communication: practice. And that's why forcing it and keeping everyone in the loop and showing them how other people communicate and how you can actually solve certain problems, how you can do it, is very good for improving those skills and also keep the team together. Transparency. Oh, I mentioned transparency in velocity already, but there is another thing. If your code review software is public and everybody can see all the reviews that are there, you cannot suddenly just say, okay, you reject patches by this guy because you don't like him, and you always make problems for him, and that other guy you like, you just accept all the patches without even reading them. If you do that, someone can call you out on that and actually point it out, hey, you are not being fair. We have some rules, we have some policies, especially if you have automation. If you require certain style of code, for instance, then you say, okay, I reject your path because I don't like the style of it. And I say, okay, then add it to the automatic linter so that everybody have to use that style and not just me, right? So it's like everybody are in the team are on equal standing. You also see pain points much better because more people feel the pain, basically, and you can better see the technical bit. For open source projects, it's especially important because you want people from outside of the project to start working on the project, right? And writing a patch for a project is like quite a big task already. So they can start small as a stepping stone, just start reviewing patches of other people and finding bugs. You get more people to find bugs in your code, which is nice. And if they like the community, they start communicating with the developers. And at some point there is a bond, and at some point they become part of your team, right? So it's really nice for open source projects as a way of attracting more people. Yeah, and all the other things in here that I listed that obviously are good for open source projects. I mentioned part of that in previous points. Okay, so code review system is a great point of automation. It's a great point where you can plug in all of your automation that checks your code. It's not just, of course, you want notifications so that people know, okay, this patch you reviewed a week ago, there is a new version of that, and please re-review it. Or there is a new patch that someone wants you to review. You also connect with the version control systems, obviously, and let people see previous versions and so on. Continuous integration. You run continuous integration, you run the tests on the proposed patch before it's actually merged. So that people reviewing this patch can see, okay, tests have passed. I can answer it or not. Also, style coverage dependencies, metrics. You can count the lines of code, you can count the psychometric measure of a function, and so on. You should connect it with issue tracker, so that when a new patch comes in that fixes a bug, it should link to the bug that it is fixing. And then you can track the life of that patch and actually know and have a callback back to the issue tracker when that patch is merged and when that patch is released. So you know when exactly the bug was fixed. You get very nice statistics. You can connect with your documentation. So this patch requires a change in documentation. And there is this change in the documentation. And for instance, all the translators have to translate that to all the languages that we support. You can integrate it with packaging. So a new hotfix is there. So you need to build a new version of your distribution of your package to deliver that to people. Also, when there is a new version released, you get to that to the bug trackers to mark the bugs as fixed and so on. Continuous deployment. That's like a harder version of continuous integration. So when a patch is reviewed, you can slowly start deploying it on your production, but not on all the servers. You can deploy it on some of the servers and see if there are any problems with them. And only like 2% of your clients will actually see some problems, but you will know instantly that there are some problems with it, right? System testing, so not just unit tests that you can run it then like that. You can have some really elaborate tests that require a whole server room of hardware, of specific hardware, and that take 2 weeks to run. And you can connect them to this. And also, okay, you won't probably see it on most of the patches because 2 weeks is just too long in the life cycle. of your code. But you will see that a build that contains that path failed at some point. Right? Next thing is test management. So at some point you actually have too many tests, and many of those tests, if you look closely at them, are just testing that mock actually works. They are mocking something and checking that it's mocked. That's quite. Or you have tests that really test one particular thing that never breaks, and so on. If you actually connect your test failures, the statistics from tests, and you keep track of which test is finding which failure and was fixed by which patch, and so on, you can have some measure of how useful a given test is. And the least useful tests can be deleted if you don't want to run them anymore, or rewritten to be more useful, right? Feature planning. Of course, when you are implementing a feature, that part that implements that feature should have all the links to the blueprints and discussions and mailing threads and everything that leads to actually designing that feature, right? So then when you go back to your patches, you can see why it's done like this. And obviously security updates. Not all code review tools support that, because with a security hole in your application, you sometimes don't want the issue to be public and the patches to be public before you actually fix the issue, right? So sometimes you need a special way, a special workflow for the sensitive changes. Tools. Okay, this is a listing of the code review tools that I found. Personally, I like Git. I know it's ugly, I know the UX is really bad, and so on, but you kind of get used to it after some time. It was actually forked from Rietveld, which both are, Gerrit Rietveld was, I think, a painter, a Dutch painter. And why Dutch? Because Rietveld was written by Guido van Rossum, who some of you might maybe at least heard about, when he was working at Google. Because Google had a great code review software that Guido wrote there, but it wasn't open source. So Guido rewrote that. It was called some other Dutch painter. I can't remember the name now. And he wrote Rietveld so that it could be open source. And at some point there was some argument in the community whether there should be control lists, access control lists implemented in that or not. And the people who said, let's implement them on our own, forget it and created Gerrit. And that's how Gerrit was born. There is a review board, which I haven't used. There is obviously GitHub and Bitbucket with the pull requests, which are basically a quite nice code review system. So I don't know if you noticed that you can leave comments on specific lines and on whole patches, and you can redo the patches and you can accept them and so on. So that's quite nice. All the Forge projects will have that, like Victorious Calidia, Fabricator, and so on. There are also some non-free solutions like the Atlassian products and so on. I won't dive into that. So this is just a listing of things you could Google for if you are looking for something. I'm not recommending any of them in particular. I'm recommending you use any of them. And yeah, why? So it's already quite a common argument. Okay, I don't need special software for code review. The kernel team uses just emails, just emails the patches, and thus review through the email. And kernel is a huge project, and they somehow managed to do it. It must be a good way. So no. This is not a good way, and it only works because of three things. First is, Linus Torvalds is not human. He's a reptilian, obviously. But no, I mean the way he can organize things and not get lost is enormous. He has a great talent for that, and don't try it at home. You are not going to do as good as it. Second thing is he uses Emacs for his mail. And he has like a metric ton of scripts in there that do all the works for him. It's like he uses a code review software, but he keeps it to himself. Right? And it's not public. And of course, all the other people in the review team use that or similar software too. But yeah, it's not public. Not everybody can use the same thing. So email right out, right? Issue tracker. Whoever tried to submit a patch to the Python core, to CPython core? Yeah. How did you like the bug tracker? Okay. So yeah, the actual process actually is submit a bug, get some discussion there, then go to the submit some patches, go to the IRC channel, talk about those patches on the IRC channel, paste in some more code. Maybe if you can actually meet a core developer in person, talk with them, convince them that it's a good idea, and then get back to the backtracker and so on. Because you really can't comfortably review code in the backtracker, and you have to save the patch, you have to apply it, you have to test. Most people don't do it, and they reject your patch on some superficial reasons and so on. So really not recommended. Fortunately, there is a PEP. I have it? Yeah, PEP 474 for introducing a code review software. I think Calisa for Python development. So there is hope. There were previous PEPs too for that, so not as much hope as I would hope. But still, yeah, issue tracker out. Branches. So just create a new branch, put your code there, and commit it, and we will just compare the branches and then merge them if we like it, and so on. Now, the version control system is already painful. Don't make it unnecessarily more painful by having to manage a lot of branches and so on and so on. Besides, the code review system probably, some of them will use branches too. You need some automation on top of them. And you need to have it for everyone, not just for you, right? So I told you about the PEPs. What's the proper pronunciation? Does anybody know? Oh yeah, PEPs. Yeah, this is an example of an official workflow for a reviewer for core CPython. And you can see it's not simple. It's even more complicated if you are submitting a patch, not reviewing it. Yeah, you can actually scroll it. So yeah, you can replace that with software. Thank you. Questions?
I was wondering if you could elaborate on what you meant by branches not being a good form of code review. So specifically something that I've tried, which mostly seems to work, is, so let's say you have like a feature branch or a dev branch or something, and the way you do code review is like you just put comments in it. The same way that at GitHub, like you can put a comment in a line, except you actually commit the line. For what it's worth, the reason that I thought it was cool was because now your version control also shows the information, so you don't have to go find, you know, like you don't have to go find a pull request or something. But I'm not sure that I quite understood why I felt that branches were not good.
Basically you need more. Branches are maybe good for like storing your information. Then maybe not, because you are mixing them up, and sometimes you want to be able to separate them to have like a better see just the important things, right? To hide them away. But apart from that, they may be a good way to store your information, but you need a better user interface on top of that.
What about the...
You can use also email, right? You could write a code review system based on email with some...
What about the clean history of the main repo after doing that?
Git?
If you try to stash your changes into one comment, you then still lose that that review information.
So
whereas in GitHub, you mostly have that available in the web UI at least.
Yeah, you could keep a separate branch for clean code.
Although if you do stash, you're losing that history as well.
Yeah, I don't know about technical problems with a specific version control system. It might be a good idea to start with branches, but you definitely need much more. In particular, you need all those hooks. You need to be able to connect it to all other of your systems, to run the script, to, I don't know, run security checks, maybe run whatever you need, right? It's a great place to put all that, because it's before the code actually gets started. So it's the last moment. Sorry.
Hello, thank you. Do you have some tips, some suggestions about how to do review for really big patches where there are a lot of code, a lot of changes, and you need a lot of time to understand all the stuff? And
well, the way we do it, we sit down and we actually review them, right? So you truth through them. One important thing is to first review it all and looking for if the whole patch makes any sense. If it doesn't make a sense as a whole, you just tell, okay, this is not a good approach, right, a different patch. Don't start by saying, okay, you have a bad style in this line. You should have a space in here. Or use single quotes, not double quotes in here. Don't start with that. I know it's easy. But first start with, okay, if we want that change at all, right? Then you look, if we want to do it in this specific way, or maybe some other specific way is better, then you go for like, okay, this line, it looks ugly, maybe write it in this way and so on. And then you say, okay, you have a spelling error in a comment in here, and also write some tests, right? So it's for the author, it's important that you start reviewing from the whole big picture, so that he doesn't, because otherwise he first fixes all your nitpicks, and then he hears that he has to rewrite the whole patch from scratch, right? That's not pleasant and not good. But otherwise, okay, you can try to split it into smaller patches, which is always sometimes a good thing. And yeah, I think that's all the tips I have.
Okay, to extend your
Where are you?
here.
Oh.
To extend your answer for this question, I think that it's cool to speed up, as you said already, but if it's a feature, then it might be cool to plan exactly something like this, because if you put something like as big as a 10,000 lines in one patch, it's crazy, right? So
Yeah, sure.
it's
For
even
large
impossible to properly.
This is before you even start using
right.
code. For large thing, write a blueprint, a proposal, think about how to integrate it, think about the migrations that will be needed and other things, and so on. Of course, that's outside of code. That's something, part of the process, obviously, of the code writing process. Yes,
Okay.
it helps.
But the real question is, what's wrong with the reviewing the patches to the email? Because, okay,
You need more. You need more. You need all the automation there, and you need them for everyone.
Let's assume it's not a very big project like the kernel or Python or whatever. There is a lot of things that. All right, but
I was prepared.
Right, but it's not a, let's say, three-line Perl script, right? We can also have something like some small projects which have some, let's say, 1,000 lines of the code.
So email makes it harder, makes it more tiring for you, makes it less likely for you to actually do it properly, because you are already tired from, I don't know, finding the email, waiting through all the replies. It makes it harder to see the overview of what other people have said about it, and so on. It's like email is time-based, right? The dialogue is like.
Yes, but what I saw already from one of the, let's say, small projects is that all the patches which are run at the mailing list is organized as a tree, which the first and the top one is the topic, which explains what the patch is all about.
Yeah,
and
so
all of
you are basically
sub-patches are separate mail, so you can just.
You actually already have a code review software, but only partially implemented using email.
Something like
Why
this,
not go
because
the
you
whole
have
way?
just the separate patches you have to look at, right? So
Yeah, that's already useful. Why,
yes, but
why stop there? Why not go all the way and have all the nice things?
because you, for some reason, doesn't have graphical
Because you can
environment, for example. Because someone has.
You don't have an account on GitHub,
Mood
right?
or something like this. No, I actually have.
No, I mean, it's cheap, right? It's not. You have free open source projects. They don't get a lot of resources. They don't need anything special to run. You can actually start them from command line with a single command. They are written in Python. You can hack them. It's cheap. It doesn't cost you much and gives you a lot.
What metrics can I use to see if I'm nitpicky enough in my reviews, or if I need, to do them more thoroughly?
That's a team manager topic, and I'm not a team manager, so I can't really help you much there. Probably what you may want to keep track of. How many reviews a patch gets? How many of them are wrong? Because some of them might be right, wrong. Which people make the most mistakes, or how fast they are learning? How much people spend actually on doing the reviews? You can do that with software, right? How long the patches actually sit in the queue, and which kinds of patches sit in the queue the longest, and which source get reviewed quickly. All sorts of anything you can think of. I'm not really a project manager, and I really don't have the knowledge to say which of them actually are useful. But you have a lot of options. So I think options are good.
So suggestion for metric. So since you mentioned in your talk, like there's a big distinction between, sure you have like senior engineer, junior engineer, but then on the other hand you have like this person likes this other person, but they really don't like this other person, so they're going to give them a really, really hard time. So let's just say that...
Like a community graph.
Right, so
of your team.
So I've looked at statistics on a project where basically you take the person who writes the code and then the person who does the review, right? And just collect those statistics. And very often you can see like some people get more review comments than others because, for example, let's say they're more junior and they're more likely to make, for example, style mistakes or something like that. But you can actually see when, and it's also important to be able to disprove, like somebody can feel that somebody hates them, but really it's not true. They complain at everyone because they're just complaining. So I've looked at those stats for a project because somebody specifically raised that concern, and let's just say that these statistics were interesting. In that, like,
I can imagine that it's
right.
like a gold mine for a project manager.
Wow, I thought we were friends, man.
Extending this for a while, we've forged a term grumpy reviewer for this. When someone has a bad day and is disapproving everything. And for my question, we all know what we can gain, and we all know the goals, but can you give some tips, some advice how to incorporate the code review in daily team basis, team routine?
I recommend just letting people do it in their own rhythm when they feel like it, because everyone has a different needs. Everyone is different. For instance, I usually do most of my reviews on Mondays when I go to work in the morning, and before I get into working, before I get warmed up, I start reading code reviews because they don't require me to be as concentrated as for coding, but like they get me in the mood for coding, right? But someone else likes to do it in the evening, for instance, or whatever is needed. Also, I have to warn you about setting a quota for reviews, because that really makes people game this system a lot. They will just, I will send a lot of small patches, and you will approve them, and you will have your review quota filled up, and so on. That really doesn't work. So just explain to your team why this is needed. And I think they will get it. At some point after you start doing it, will not want to stop doing it. They will see it is actually beneficial. Yes?
I think I have another solution for you. In my case, I think it would be the up and down voting system with logic, like you can actually implement it in Gerrit. So even we get one hater in team which has bad mood that day, you still have a lot of others, very optimistic coders, and looking at your review with pleasant eye, and you still have make a logic like 3 votes up and 1 down, so it goes through the review and it's fine, and then it goes to be merged.
So how you are deciding how to merge a certain part, it's very specific to a project. Even in OpenStack, each part of OpenStack have their own rules for that.
Basically, so because you can...
It's very specific to a particular team and particular project because the needs are so different. So usually that part you can tune it pretty well and configure your system pretty well for the rules of accepting. Usually we actually have approvers and all the other people, and all the other people can only give +1 or -1, and that does nothing. This actually always shows you approval or disapproval of the part. And the core review team, which is like 5 people, have the power to give +2, which or -2 blocks the part. It cannot be met until the -2 is removed. And +2, we have a rule that as soon as a part gets 2+2, from people from different companies, because it's open stack and we look at each other's hands all the time, as soon as there are 2+2s, we can have it. So that works for us. What works for you, you have worked for you. There is no one single answer that works for everyone.
I think the original question was about the tip to start using the code reviews itself. So I think that it has to be part of the process itself, because otherwise the people are too lazy, especially we are the developers, we are lazy, right? So
you can have weekly meetings, you can
yes,
daily meetings.
Right, but on the other hand, if no one will do the reviews, then it doesn't make sense.
You need
so it has to be the part of the agreement or whatever you call it as a process.
Well, you cannot force that on people. You have to have them agree to do the reviews. Forcing it on them won't work. Better just lie it off and just don't do it if you are trying to follow. But usually developers will see it's good and will understand it.
That was the last question. Thank you very much, Radomir. The next talk will start in 5 minutes.